Hello everyone, my name is Adrien Chaffangeon and I am a third-year PhD student from the University of Grenoble. Today, I was hoping to present a paper about microgesture interactions, the main topic of my PhD. I would have explained that microgestures are fast and subtle finger movements, and I would have shown that microgestures allow all-three interactions in parallel of a primary task, such as driving. However, while looking through the literature, I had issues in comparing the different papers. To make you understand why, let's play a little game. I'll show you a microgesture, and you'll give me a name. Okay, here's the first one. So think about a name for it. Go ahead. You can even try to think about 2 or more names. Okay, if I could read your mind, I think the results would look like this. A majority of people have recognized the action of cutting with scissors, in other words, to snip. Others may have recognized a tap or an open-close gap. So, what is the correct answer? Well, there isn't. All 3 names are from the literature. We have a first issue here where the same microgesture has different names in the literature. Okay, so if we were to play again and you try to guess what an extension microgesture is, I think most of you will guess that an extension is opening its finger. In fact, in biomechanics, an extension is the fact of opening a finger joint. But wrong answer. In the literature, an extension is indeed opening its finger, but while staying in contact with an object. The name of simply opening its finger in the air is extend. So here we have a second issue. Different microgestures have the same or very similar names, which can lead to confusion. These 2 issues about naming macrogestures wouldn't be that big of an issue if macrogestures are precisely defined in the paper. But in the literature, microgestures are often described using only a name or a picture, but seldom with a precise description. Thus, this can lead to interpretation issues. To summarize, while doing my literature review, I was faced with 3 issues. One microgesture can have different names. Different microgestures can have the same name. And lastly, microgestures are often defined using only a name and an image, which create ambiguous descriptions. So, now let me restart my presentation. Hello everyone, my name is Adrien Chaffangeon, and today I will present µGlyph, a microgesture notation to precisely define microgestures. µGlyph has a set of core elements to describe the direction of the movement and whether the finger is in contact with a surface or not. With the µGlyph notation, we associate with each of these 2 elements a visual symbol called a glyph. Let's start with the movement glyph. According to the biomechanics of our finger, a finger can move in 4 directions, which are represented by a triangle orienting in the corresponding direction. We add a last type, the absence of movement. The movements are represented by a triangle by analogy with the play button of a player. Thus, the absence of movement is represented by a square by analogy with the stop button. For the contact glyph, we represent the finger in contact with a filled circle and the finger in the air with an empty circle. Okay, now let's see examples. First, we consider a downward drag of the finger. The finger performs a flexion, represented by a triangle pointing downward. This glyph is placed in the middle of our representation. And then, for the contact glyph, the finger is in contact at the beginning and at the end of the movement. So we have 2 filled circles that we place above the movement glyph. Here we have 2 circles because the beginning and the end position are different. But sometimes, these 2 positions are the same. This is the case for a press. The finger flexes toward the surface of the object, thus increasing the pressure of the finger on the object, but the finger doesn't move. So we represent a press as follows with only 1 contact glyph. With this glyph, we can represent and differentiate between several microgestures. Here we have a press, a downward drag, an upward drag, and a release. We can note that changes 1 glyph changes the whole microgesture. For now, we can define a microgesture using the movement and contact information. However, to be more precise, we sometimes have to specify some characteristics of the movement. For instance, we want to specify the finger that does the action, also called the actuator. To do this, take your left hand facing you. Each finger will be represented by a dash to form a hand shape. Then, let's imagine that it's my index finger that moves. I replace the dash representing the index with a flexed glyph, and as it moves, the index finger comes into contact with the thumb. My index finger came from in the air, represented by an empty circle, to in contact, represented with a filled circle. And since my index touches the thumb, we replace the corresponding dash with another contact glyph. Here, the contact surface was the thumb, but it could also be a particular phalanx, my palm, or an object. And for each of them, we have dedicated glyph. Finally, sometimes we have to precise parameters of the movement, such as pressure, duration, and amplitude. For instance, for the case of a press, the pressure changes from low to high. Here, it is represented under the movement glyph, using an arrow to convey the change in pressure. So far, I have presented all the basic elements of the microglyph notation: the movement, the actuator, the contact surface, and other parameters of the movement. So now, let's consider how to combine these microglyph representations. Since I recall, so far, we only know how to describe microgestures consisting of a single movement. But this is rarely the case. A tap already consists of two movements. I go down, represented in microglyph like this. Then, I go up. Well, this then is represented by a semicolon. Now, let's say you want to create a choice between two specific microgestures. For instance, a choice between a touch of the index finger on the thumb or a touch of the middle finger on the thumb. While using microglyph, we will separate the two microgesture descriptions with a pipe symbol to represent an or. Finally, let's imagine that instead of a touch of the index or middle finger, you want to specify an index and middle finger touch. That is, you want these two movements happening in parallel. Well, we'll simply put parallel bars between the two microglyph representations of these movements. So, with these three extra symbols, we now have all the symbols of the microglyph notation. To evaluate microglyph, we first presented its expressive power by translating microgestures from the literature. In total, we have a database of 118 microglyph representations from 17 different papers that you can see here. Moreover, for each representation, we have extracted its name, its textual description if any, its image description if any, and what object, if any, the hand was holding. In a second evaluation, we compared microglyph, concise microglyph, which you can find more detail on it in the paper, but it's basically microglyph taking up less space, and text plus images taken from the literature. We had 20 participants, mostly HI PhD or PhD students, that read 10 microgestures for each kind of microgesture descriptions. We found that while reading microglyph is slower than text plus images, participants found the proper microgesture 90% of the time with microglyph and only 46% of the time with text plus images. Moreover, participants also had to write 10 microglyph descriptions using microglyph or concise microglyph, and they wrote it correctly 91% of the time. In the end, microglyph is precise, microglyph is exhaustive, but most importantly, microglyph is usable after a training of 20 minutes only. But this is not enough. If I want you to use my notation, I have to promote its usage. And to promote the use of microglyph, I have one more thing to show you. We built and are building a set of tools around microglyph. It compiles the 118 microglyph representations I talk about. You can search through them by name or even using microglyph. You can visualize them in 3D, in 2D, and export them in SVG. And we provide you with tools to easily integrate microglyph in LaTeX. So I will let the video looping in the back, and I can do a live demo if you have further questions on the tool. If you are interested in collaborating on microglyph, you can use the QR code to go on my personal webpage. By the way, I am also looking for a postdoc next year. For those of you who like challenges, you can try to guess the microgesture represented here during the last few minutes we have together. Thank you.